What would you think if I told you that reality is about to exceed fiction? Today we are going to examine the most ambitious idea of Elon Musk. I suppose you have already heard about Elon Musk and his visionary projects. Today I will detail Neuralink, its history and its achievements, taking in consideration 8 points: neuroscience, transhumanism, a brief timeline, idea, the design, the device, the sewing machine, and the future of Neuralink. Let's start talking about neuroscience. Before, I want to show you an extract from the movie Transcendence of 2014 that fits perfectly because Neuralink would not be possible without
the combined intellect of the neuroscientists, engineers, mathematicians, and hackers. This auditorium pales in comparison to even the most basic AI.
Talking about neuroscience, it studies the cellular, functional, behavioral, evolutionary, computational, molecular, and medical aspects of the nervous systems. There are many fields that focus on different aspects, but they often overlap. Neuroscience affects many, if not all, human functions, but it also contributes to a better understanding of a wide range of common conditions. All of this takes us to the second point: transhumanism. Why is Neuralink related with transhumanism? To answer this question, remember that natural selection is a biological process where, through thousands of years, have given birth to every species that walks our planet today. Typically, the process that changes one species into another takes centuries, if not more. And what if we could skip this biological process entirely? Well, it may be possible as long as technology significantly upgrades human life and behavior. Max Moore in 1990 defined the concept of transhumanism as follows: transhumanism is a class of philosophies of life that seek the continuation and acceleration of the evolution of intelligent life beyond its currently human form and human limitations by means of science and technology, guided by life-promoting principles and values. At this point, we have talked about the two big pillars of Neuralink, but when did it start? Neuralink was founded in 2016 by Elon Musk and a group of experts in different areas. The company's headquarters are in San Francisco, California. By April of 2017, the blog Wait But Why reported that the company was aiming to make devices to treat serious brain diseases in the short term, with the eventual goal of human enhancement. Musk said his interest in the idea partly stemmed from the science fiction concept of neural lace in the fictional universe of the culture.
I don't know if a company that's working on it seriously um, is a neural lace.
A year later, by 2018, the company had remained highly secretive about its work since its launch. Furthermore, Elon Musk smoked pot and drank whiskey on the Joe Rogan podcast, and he said he was going to announce a new Neuralink product that can make anyone superhuman.
It's like the purpose of Neuralink is to create a high bandwidth interface to the brain such that we can be symbiotic with AI. Because we have a bandwidth problem. You just can't communicate through your fingers, it's too slow.
Musk said this sort of technology could eventually allow humans to create a snapshot of themselves that can live on if our bodies die. He said, if your biological self dies, you can upload it into a new unit. Literally. If you have seen Altered Carbon, you will relate this idea of Neuralink with a device called Cortical Stack in the series. By July 16 of 2019, Elon Musk hosted a presentation about Neuralink, letting the world know the latest news about this cutting-edge technology. He has previously said that the technology is supposed to create an interface between the brain and computers, creating a greater bandwidth in the mind. Since its founding, the company has hired several high-profile neuroscientists from various universities. By July 2019, it had received $158 million in funding, of which $100 million was from Musk. Last year, in July 2020, according to Musk, Neuralink obtained an FDA Breakthrough Device designation, which is a voluntary program designed to help expedite the development, assessment, and review of breakthrough technologies. The same year, at a live demo, Musk described the device as follows.
This is our little device. That thing at the bottom is just to hold the threads in place because they're just like little fine wires. In a lot of ways, it's kind of like a Fitbit in your skull with tiny wires.
He said, a Fitbit in your skull with tiny wires, which could soon cure paralysis, deafness, blindness, and other disabilities. In spite of their progress, many neuroscientists and publications have been criticized these claims. But what was different in the last demo? As I mentioned, the last August the company held a live demo of its technology. Musk showcased three pigs, one without an implant, one with an implant from 2 months before, and one who previously received an implant. The implanted pig, called Gertrude, gave off a sound indicating that areas of its brain associated with its snout were active. In addition, the link accurately predicted the location of the implanted pig's limbs in real time while it walked on a treadmill. In an interview on January this year, Elon Musk revealed his brain implant startup Neuralink has successfully embedded its proprietary chip into a monkey's brain, allowing it to play video games. So, just an average Sunday night for the exceedingly busy billionaire. We have a monkey with a wireless implant in their skull, with tiny wires who can play video games with his mind. Musk told several thousand listeners in a Clubhouse chatroom, "You can see where the implant is, and he is a happy monkey. We have the nicest monkey facilities in the world. We want them to play mind pong with each other." Elon Musk's Neuralink company is looking to test brain chip implants on humans this 2021. Musk publicly responded to a Twitter inquiry from someone interested in being part of Neuralink's clinical study, and shared that his neurotechnology company is currently working super hard to prepare for this scientific feat. Right now, we are going to detail the overall idea of Neuralink. The idea is not new. Scientists have been testing brain implants on patients that allow them to move computer cursors or robot arms for about 15 years ago, but only in research settings. These videos are from 2016, the year where Neuralink was just an idea.
Index, ring.
So Matt, I'm gonna go and turn on the arm. Try and go up. Okay, and back down.
This is the most complex robotic arm in existence today. You can control that using thought from the brain. As humans, we are tool users. And every time we invent a new tool, that changes the way we live.
The technology itself is not new, but Neuralink wants to make the system smaller, safer, and easier to insert, and if that goes well, the company has a host of bigger goals. People are already a cyborg in that you already have a tertiary digital layer, Musk explained. He described two biological layers to the human brain, including the limbic system, which controls your primitive drives and desire, and the cortex, which deals with the executive functions like long-term planning. The third layer, Musk said, is the smartphone in your hand and all the information that you can harness through it. At this moment, we face a problem. In Musk's words, the bandwidth between your cortex and your digital tertiary layer is very slow, and in fact, with the advent of phones, it got even slower. Musk said, "At a certain point, the computer gets smart enough. It's like the computer is trying to talk to a tree. That means our brains do not talk to computers fast enough." Now we're going to talk about the design approach. Neuralink is a system that involves ultra-thin probes that will be inserted into the brain. A neurosurgical robot that will perform the operation and a high-density electronic system capable of processing information from neurons works as follows. The inserter approaches the brain proxy with a thread. The inserter touches down on the brain proxy surface. The needle penetrates tissue proxy, advancing the thread to that desired depth. And finally, the inserter pulls away, leaving the thread behind in the tissue proxy. Talking about Neuralink Electrodes, they are fabricating minimally displacive neural probes that employ a variety of biocompatible thin film materials. The main substrate and dielectric used in these probes is polyimide, which encapsulates a gold-thin film trace. Each thin film array is composed of a thread area that features electrode contacts and traces, and a sensor area where the thin film interfaces with custom chips that enable signal amplification and acquisition. A wafer-level microfabrication process enables high-throughput manufacturing of these devices. 10 thin film devices are patterned on a wafer, each with 3072 electrode contacts. Chronic recording from thousands of electrode sites presents significant electronics and packaging challenges. The recording stack must amplify small neural signals, less than 10 microvolts, while rejecting out-of-band noise, sample and digitize the amplified signals, and stream out the results for the real-time processing. All of this using minimal power and size. The electronics are built around Neuralink Custom Application Specific Integrated Circuit, called ASIC, which consists of 256 individually programmable amplifiers, an on-chip analog to digital converters, peripheral control circuitry for serializing the digitized outputs, and a consume of approximately 6 milliwatts, including the clock drivers. Identified with the letter A, we can see the individual neural processing ASIC capable of process 256 channels of data. This particular package device contains 12 of these chips for a total of 3072 channels. With the letter B, we can see the polymer threads on parallel C substrate. Identified with the letter C, you can look at the titanium enclosure of the ASIC. For the last one, there is a digital USB-C type connector used for power and data. So let's move on and continue with the device. As we saw it, on 2019, Neuralink presented the N1 sensor, a very small implantable sock that has a number of extremely thin external threads that measure 4 to 6 micrometers in width. That's much thinner than a human hair. In its most basic sense, the sensor was capable of measuring spikes in electrical current directly where they happen in the brain, with the intention of reading, processing, and eventually writing information back to neurons via these tiny and flexible threads. The first idea for Placeit was the Fitbit in our school, just like this. Although, as we saw it, last August Neuralink showed to the public their progress, and we can summarize it in these aspects. First, the Neuralink implant device has been dramatically simplified and it is called Link B0.9. Here you can see its new design. Second, the implant device is inductively charged, much like wireless smartphones are charged. Also, the Link B0.9 has new characteristics. For example, it has 1024 channels per link. It is about 23 millimeters of radius and 8 millimeters of thickness. It is not external visible. It has 6 axis inertial measurement unit, temperature and pressure sensors. It has a megabyte wireless data rate and all-day battery life. The question here is how they have achieved to implant this device. This robot has the ability to make precise movements necessary to implant very thin threads into the brain. It sounds like a simple task for a robot, but at that microscopic scale, it becomes a task as complicated as landing a space rocket safely back on Earth, and you know Musk is all too familiar with. Otherwise, the surgery is not possible without the robot. The reason, at that scale, there are other factors that it must consider. For example, breathing and heartbeat. Neuralink is an undeniable and innovative project, an idea of progress, of having a computer inside everyone's brain. With time, it will become a tool as our phones today. There is so much unexplored field, and so are the dangers and the threats. Maybe this idea came out of a Black Mirror episode. Today, I am very eager to imagine more of what it will bring for the future of human intelligence. Will I try version 1? At this point, probably not, but I cannot speak for future me.